Hello, this is going to be lesson 2.9, which is the last of unit 2, and we're going to talk about two variable inequalities. So we've already talked about inequalities as far as solving goes. However, in this section, we're going to talk about inequalities in graphing and what that looks like. So back to linear inequality, it's when we have two variables whose graph is a region of the coordinate plane that is bounded by a line. So you'll see what that looks like in just a few moments. The boundary is the line itself. So when you draw the graph, that boundary is that line that you graph is the boundary. Now, this goes back as well, I think possibly to Algebra 1. But if I were to have a greater than or a less than, that would be a dotted line boundary. So dotted line. And if it's greater than or equal to or less than or equal to, that would be a solid line. And those are both boundaries. So that we will again talk about as we do it. Half plane is a set of points that basically make up the answer. And so half plane is not something that I frequently call it. And actually, I don't think I ever call it that. It's just where the solution lies on the graph. And you'll see that when we graph them. And the test point is a point you pick on the graph to determine which side of the boundary line is your half plane. And so when you're graphing it, you're going to draw your line, you're going to pick a point, and the easiest point to pick is typically 0, 0. So if it is not on your boundary line, we're going to use 0, 0 for my point for testing. Use 0, 0 to test if not on boundary line. So as long as it's not on the boundary line, we are going to use that to test. Now, if it comes out to be true, that means that's where your answer would lie. And if it is not true, that means that the other region is where your answer lies. All right, on to the 6. So this one's going backwards. What if you have the equation, but we need to write the inequality? So we're going to pull apart all the important things that we need. So in this example here, I have a line. So we know we're going to fill in y equals mx plus b. And we need two important things for that. Whoops. We need the slope and we need the y-intercept. So let's start with the slope here. Slope, I'm going to pick a point and I'm going to find 2 points here. So in the slope, it's rise over run. So I'm going to go down and over. So if I go down 1 and over 2, that means I have a slope of negative 1 over 2. Now my y-intercept, I kind of happen to pick it right there. That's my y-intercept, that's b. So that is the coordinate of 0, 1. It is a dotted line, which means that is going to be less than or greater than, but the line is underneath. So we're shaded below. So we're going to do less than, and it's less than dotted. So with all that information, let's put it together. Y is less than negative 1/2 x plus 1. That's my equation, and that is going all by y equals mx plus b. 7, we're going to do the same thing, but 7 is an absolute value. So in absolute value, we're going to do the same process, but we know that it's going to be some sort of version of this. So let's start with my vertex. Okay, vertex. That is going to be, in this case, negative 1. Whoops, what did that scram down for me? Negative 1, 1, 2, 3, 4. So negative 1, 4 is my vertex, so that is my h and my k. It is a solid line, and you'll notice it is above the graph, so that means we're doing greater than or equal to. And if we look at the slope to double check, we see this one is going down and is going over 1. So the slope here is going to be a negative 1. And we're going to plug it in. So y equals a. So a is driven by my slope, so I'm going to put a negative 1 in there. Absolute value of x minus h. So x minus a negative 1. Remember, we have minus a negative. That makes it a plus 1. And then plus k at the end is your 4. So this would be your final answer. Number 8, next part. So this is visually what we were just talking about. So the boundaries, so this right here is boundaries and half planes. So this portion of your graph right here, this is where your half plane would be. if that is where your solution lies. Boundary line. There we go. So that's a boundary line. That part is a half plane. And then same thing over here, just to show you two different ones that might show you what you're looking for. So this is your boundary line. Wow, my spelling there is bad. And then your half plane. So y equals mx plus b. That is your boundary line. It's just your line. All right. When and how to shade the planes. So when I have something like this first one, this one says greater than. So greater than does not have a greater than or equal to. So this right here means it's going to be dotted, which you can already see it is. And then it says greater than. So greater than is going to be shaded in the region that is greater. So that's my S for shading. So greater than the line. So what that means is if I took the point 0, 0 and I plugged it in, 0 is greater than 0 minus 2. So 0 is greater than negative 2, which is a true statement. Over here, we have greater than or equal to. So this one shows us we have a solid line. And this one also says greater, so it is going to follow the same rule where I'm looking above. But I'm going to give you a different test region outcome here. So if I put in my 0, 0, I have 0 is greater than or equal to. If I were to multiply 0 times this, it's gone. So that's 0 plus 1. So is 0 greater than 1? That's not true. So what that tells me is that this area is false. And so this should be my shaded region up here. So that's how the test region works. Okay. Up here, again, we have a dotted line. That tells me dotted. And this one says less than. So hopefully you'll learn to see the pattern of what's happening here. But less than, again, if I picked a point and plugged it in, 0 is less than 0 minus 2. 0 is less than negative 2 is not true. So that means this is false, which means my shaded region is over here. Let's do a different color. So this is my shaded region. All right, and the next one, so solid line and test point 0, 0. So 0 is less than or equal to. Remember, this portion becomes 0 when I multiply it. So we have 0 plus 1. So 0 is less than or equal to 1. Well, that is a true statement. So that means my shaded region is on the side of that point, which is my solution right there. Okay, great. Now we're going to go on to example 4 right here. There we go. Now, when we're doing the things that we learned about last time with the absolute values, we're going to combine the two pieces now. So I'm going to still use how I learned how to graph it, the absolute value, but I'm also going to shade it because we have an inequality. So in this case right here, we go back to what we just learned. So I have my vertex, this is my A, my H, and my K, just as a reminder. And so the vertex comes from opposite of H, so that's going to be 1, and K, which is negative 3. So there's my vertex. The A tells me that my slope is going to go down and 1 over. So I'm going to start with my vertex at 1, negative 3. So 1, negative 3. And my slope is down 2 over 1. My boundary is going to be solid. This one has two boundaries because it's both parts of this. And the shading of this is going to occur, and we'll talk about that in a second. 1, 2, let me graph this first. All right, so solid line, solid line. So there's my absolute value. And now the shaded region. So we can do the same thing we have been doing with the 0, 0. So if I plug this in, I have 0 is greater than or equal to negative 2, 0 minus 1 minus 3. So I get negative 2 times, this becomes a positive 1. So negative 2 minus 3, 0 is greater than or equal to negative 5. That's true. So that means this shaded region up here is where my solution lies. Notice how that is above the line. Oops, I didn't want to write it there. That goes with the shaded part. That is above that line, or above the graph. Just keep that in mind again. All right, we're going to do next one. So this one we have to do a little bit of isolating first. So we want the y by itself, so I'm going to move this over. So I'm going to have negative y is greater than the absolute value of x plus 2 minus 4. But then I also have a negative. So that negative is going to change a couple things. So this negative y is what I'm talking about. So if I were to multiply everything by a negative 1, so if I multiplied everything by negative 1, I end up with y. I have to change the inequality. I have a negative 1 here. That's out front of that. And then I change my sign of 4 to positive 4. That gives me my vertex at opposite of h, k. My boundary is going to be less than, so that is going to be dotted. And if I had to guess with you guys, the less than means we're going to shade below. And we can verify that as we do it. So let's go ahead, and we also notice, sorry, I didn't mention this. I didn't write it down when I should have. The slope on this one is a negative 1, so that means we're going to be going downward. So I'm going to start at negative 2, 4. I'm going to go down 1 over 1, so the standard absolute value graph. And then, wow, this one's a big one, is a dashed line. So this is dotted here. Dot, 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 dot. Okay, so now if we were to do a test region here, picking that point 0, 0, I would plug it in again. 0 is less than negative 1. 0 plus 2 plus 4. So 0 plus 2 is 2, negative 2 plus 4 is 2. So is 0 less than 2? That is true. So that means my shaded region is below this line, underneath it. There we go. On to the next. So example, that was 5 and 6, is our... I'm going to find it. Example 1. So example 1, this is what we have. It is a line. Remember that it's just a line. It has a slope and a starting point. So the type of boundary line, let's start with that. So boundary line comes from this. That's your greater than or equal to. So greater than or equal to means we're going to have a solid line. And the line is going to be of the equation negative 2x plus 1, because we graph it as if we were normally graphing. So let's start with that. So negative 2x plus 1. So my slope, my y-intercept. So starting at my y-intercept, I have 1. My slope is negative 2 over 1. So down 2 over 1. And I'm going to do that in both directions so that I get a nice long line here. And it is a solid line, so I'm going to go ahead and draw a solid line through these as best possible. So there's the graph portion, and then it says test point. So we're going to do the same thing. We're going to pick a test point. So I'm going to use 0, 0, and I'm going to plug it in. So 0 is greater than or equal to negative 2, 0 plus 1. So 0 is greater than or equal to 0 plus 1. Is 0 greater than 1? Nope, that's false. So that means my shaded region is not there. My shaded region is the other side completely. And that's my answer. What that means is that anything in that shaded region, that half plane that is shaded, that right there would solve my slope problem. So if I picked any coordinate there, it would make the graph, the equation here, true. Next example, number 2. So number 2, boundary is going to go from the, let me grab something here. So less than, this is going to be a dotted line. And then we're going to do it of the graph that is y equals negative 2x plus 1. So that is the same graph that we had above. So we're going to graph the same thing. However, the difference is my less than, not greater than or equal to. So I'm going to go ahead and sketch out my graph here. This one is a dotted line, so I'm going to draw that the best I can. And this time I am going to do the same test point, but do I really need to do it again? Not really, because the above, I know that that comes out to be 0 and 1. The only difference is this part. So that portion right there, if I were to plug that in, I guess I'll plug it in anyway. Plus 1. So this equals this. So 0 is less than 1. Well, that is a true statement. So that means that it is true on this side this time. So that means my shading will be over here. And you'll notice that is shading below, whereas this was shading above. Keep that in mind. It'll save you some time. All right. So we're going to example 3. I'm going to find it. Next one. So for our first word problem here, Tina's going to buy P pounds of pasta salad and C pounds of chicken salad for a party. The pasta salad costs $4 per pound of chicken salad. And then, I said that wrong. Pasta costs 4 pounds, chicken salad costs 6 pounds. She has at most $28 to spend. So that means she can't spend over that, but she could spend $28. We're going to write a graph and inequality that describes the relationship between P and C. All right, so with that said, we're going to relate the two of them. So we know we have $4 for pasta, and it is $6 for chicken salad. So I'm going to use the P and C as stated here, and it says at most 28. So when I see something at most, that means I can't go over, which means I need to have less than or equal to $28. So we're going to graph this. Now, in order to graph it though, I kind of need to have it in a format that's easier to graph. So I'm going to do a couple things. First, in order to do this, I'm going to get one of the variables by itself. I kind of want to think intuitively about this, meaning I want to, if I'm going to bring over and isolate P or C, I kind of want to make sure I have some nice numbers. So what I do notice is that 28 and 4 will eventually, if I divide them, that would work. And so I'm going to try not to divide by the 6. I want to make it the 4. So I'm going to do that by subtracting the 6C to the side. So I end up with 4P is less than or equal to -6 plus 28. Whoops, I forgot my C. And then now I'm going to divide by 4. And so I have P is less than or equal to -3/2C plus 7. So see how that came out to a nice 7? Just kind of makes it easier for the graphing portion of things. So now we're going to graph it, and I have two parts. I have pasta salad and I have chicken. So P is in the position of what Y would be. So we're going to make my y-axis pasta and my x-axis chicken. And now we're going to graph. So I'm going to go up to 7 at my starting point. So 1, 2, 3, 4, 5, 6, 7 is my starting point. And my slope is -3/2. So slope, y-intercept. So down 3/2. 1, 2, 3, 2. And there are 3 points. And it is a solid line. There we go. Now, the solution is going to be in the region that meets all of these things. Now, it says that I can't spend more than $28, and so we are still going to double check. If I plugged in 0, 0, which is my coordinate here, if I plug that in, I would have 0 is less than or equal to -3/2, 0 plus 7. So is 0 less than or equal to 7? That is true. So that shows that my shaded region would be in that area below. So this right here is my shaded region. Now, what that means is that in order to spend exactly $28 or less, she can use any combination in the shaded region. So any combination in the shaded region will solve this problem, any of those. Okay. Example 4. There we go. 8 says you want to buy a favorite candy bar that costs $1 each and your favorite pepperoni snack that costs $1.50. You have $4.50 to spend. So we're going to write an inequality very, very much like what we just did before. So this one we have candy bar and we have pepperoni stick. And we have only $4.50 to spend. So candy bar costs $1. So that would be 1C, but I'm just going to put in C. I have $1.50 for pepperoni sticks, and I can't spend more than $4.50, but I do have $4.50. So I'm going to say that's probably another less than or equal to. And in order to graph this inequality, I again want to isolate. So in this case right here, let's go ahead and subtract C. So 1.5P is less than or equal to -C plus 450. And then if I divide this, divide by 150, 1.5. P is less than or equal to. So 1 divided by 1.5. So let me just do a little math here for you guys. 1.5 is 3 over 2. If I do 1 divided by that, I'm basically just flipping and multiplying this, which means I end up with 2/3. And it is a negative c, so I want to make sure I have that there. And then 450 divided by 1.5 is a solid, I'm thinking here, I think it's a 3. I'm going to double check for you. Divided by 1.5 is 3. Yes, so very nice number. So there is my information for graphing. So let's go ahead and we're going to do the same thing we did before. So in the position of x is my, not x, y is my pepperoni. And in the position of x is the candy. And we graph. So at 3, I have my y-intercept. I have a slope of -2 over 3. I guess I should have spread that on more. It's not a very big graph. Guess I can't buy too much. So what I have here, let's go ahead, and we are less than, and so hopefully you've caught on with the less than. We could plug in 0, 0, but less than means less than the graph. This one says, why is the graph in B only in quadrant 1? So if we look at this graph, it's only in quadrant 1, and my other word problem was the same way. And the reason is because I can't have negative money or items. So because there cannot be negative, cannot have negative money or items, then it wouldn't make sense to go into the negative. It wouldn't make sense to have a different quadrant because I'm dealing with something that's actual real life. And then part 3 says, or not part 3, part D says, can you buy 3 candy bars and 2 pepperoni snacks? So 3 candy bars, so I'm going to do this on the graph first of all. So 3 candy bars is 1, 2, 3. That's for candy. And then 2 pepperoni sticks. That puts us up here. So for part, let's do this. For part D, 1, 2, 3, 1, 2. That right here is where part D is, and that's not within our region. So no, they cannot have no 3 candy and 2 pepperoni are outside the solution set. It is outside of where it actually works for a problem. All right, I think that covers it now. All right, so homework is to do the 2.9, and don't forget to do the 2.8 homework check on the link attached in Google Classroom if you haven't done it already.